Hello everyone, this is the part 2 of the session 2. In last part, we have manually create a rectangle 20 by 20 numbers and we saved these numbers and load those numbers to Python. We also has measured that the numbers has a 2 meters resolution and the top left corner is like this. Now in this part, we will load this data and save it as a GeoTIFF. Okay, now let's go back to this Python file of VS Code. Let's close the interactive window and rerun everything from start. So we highlighted every line and run and hit Shift and Enter. That means we will rerun all this highlighted code. After a while, we could say, yeah, the simple smile div has a shape of 20 by 20. Since now we get the numbers, now we need to define the geotransformation of the smile EF. Let's go back to the slides and copy all the geospatial information back to VS Code. This number is the Y of the top left corner. This one is here. Let's go back to VS Code. So we can give it a name of Y equals this. Similarly, X equals to this one. And we also know the CRS stand for coordinating system is EPSG is now 3857. Coordinated system means CRS means coordinate preference system, and the name is Mercator. We know the Y size equals 2 meters and X size is also 2 meters. Let's run all of this code. So now the Python knows this number. Alright, so now we have all this piece of information. The question is, we as a human understand all the meanings of these numbers. But as Python, we have to organize this information in a format that Python understands. So here, I've been asking ChatGPT of what are the transformation numbers in raster stand for. Here, he'd give me a little example of how to organize this geospatial information so that Python understands. I will copy it back to my code and paste it there. Basically, we need an affine function or affine definition to put the first number as pixel width, which is the height of which is the Y size. The third number is the top left X, which is the X, and negative pixel height, which is the Y size, and the top left Y, which is the Y. So we can create a variable named affine. The essence is we translate human readable information into a format that Python understands. In essence, this stands for the same piece of information, aka the top left corner of this image, which is this point. Now, since we have the numbers and the geospatial reference, we need to combine numbers with affine to create the GeoTIFF. To create a GeoTIFF, what we need is raster. So here, there has this white curly. That means raster is not installed. In the same story, we need first conda activate GEOENV to get inside the GEOENV environment, and then conda install rasterio and hit enter. After a minute, Python will install this rasterio for us, so I will stop and recording after then. Okay, now we can see the curly underscore is gone, so rasterio is installed. Now we combine geotiff diff with transform to create a raster. So first, let's combine all these informations. So meta, let's give it a metadata equals a dictionary. The first key is driver, and the value is gtiff. That means we want to create a GeoTiff file. The count is 1. That means the file we create is a 1-bind file. And the data type is integer 8 because the numbers are zeros and ones. And the width and height are essentially the smile.shape. We want to create a raster or GeoTiff file that is 20 with the size of 20 by 20. CRS, coordinate reference system, we were using this EPSG, this one. And the transform, we will use this affine. Okay, that the affine is not defined, that means we are not executing this block yet. So let's re-execute affine. It will show here. Now that we have the geospatial information and the values, we can save them as a GeoTiff. The command is with rasterio.open. This is the file path where we want to save the data. It's under data folder. We'll give it a name as SmileTiff. And this W means we will write to this file. And this metadata, this double asterisk and the metadata means we will specify these key value pairs as arguments. For example, we told rasterio that the driver is gtiff, the width and the height of this file is like this. And inside this with statement, we write down dst.write smiledf.values. This is the smiledf, and we really want is the values. We don't need this column indexing and the column names. We just want these values. We will write these values to the first band. And by executing this, we successfully saved the numbers as GeoTiff. Now let's start up a QGIS, and we can drag this SmileTiff inside QGIS. We can see, it's a smile face that looks good. And then we can overlay this Smile GeoTiff on Google Satellite image. So we move Google Satellite on bottom. Yeah, that's the magic happens. It's not perfect. We can see a large mismatch of the Smile GeoTiff. That is because when we transform the top left corner, here, from WGS to Mercator, there will inevitably some errors happen. But the key is we now understand that a GeoTiff is by essence just some numbers, and these numbers has the geospatial information is the top left corner coordinates, the height and the width, and each grid cell's height and width. By knowing all this and organizing them in a reasonable format, we can create GeoTiffs. Okay, that's this session.